So you've learned how to do systems of inequalities and systems of equations by graphing. Now we are going to do systems by substitution. Okay, you guys are pretty good at substituting regular numbers, okay, but now we're going to substitute equations, all right? So let's quickly go over how to writing a system from context. Okay, so I'm going to say that my brother is 2 years older than me. Together, the sum of our ages is, let's see, 54. Alright? So we need to be able to write the equations before we can solve them. So we're going to quickly go over this. So my brother, we're going to say is, that is B. So we're going to assign values to the letters. Okay, so B equals brother. And M will equal me, Miss Barna. Okay? So my brother is the older one. So he's 2 years older, so you would think you want to add to him, but he's the older one. So we actually need to think he is my age plus 2. So you got to start with the smaller person before you add, if it's talking about ages. And then the sum, that means we're adding. So his age plus my age is 54. Okay. Now, we're going to use this thing called substitution. Okay. It is best used when one variable, either the b or the m in this case, is by itself. Okay, so I see this one, the b is all by itself. Okay, so it equals m plus 2. Well, I can plug that in for this b down here. Okay, so I'm going to rewrite this equation. I'm going to use parentheses to put it around m plus 2 because I'm substituting in. And then the rest of the equation stays the same, plus m equals 54. Now, if I don't have to distribute by anything, I can just drop the parentheses. So m plus 2 plus m equals 54. The reason we want to do this is we want to get one letter. Not one letter, the same letter, okay? So you need one variable solved. So one variable is isolated. Okay, it's by itself. Alright? And then we need to substitute equation. Okay? It's not just a number anymore. We're substituting this whole thing. Okay, and we do that so that we have the same letter. Then we're going to solve for the variable. I now have one variable, so I can combine like terms. I have an invisible one here, I can add, and an invisible one here. These are my like terms, so 1 plus 1 is 2m. And now I can do my inverse operations. So subtract 2 to both sides, and we get 2m equals 52. Divide by 2 to both sides, and we get m is 26. So we said that m is me, so that means that Miss Barna is 26 years old. Well, how do we then know how old my brother is? I can take this right here and plug it in here. So I've got b equals m plus 2. M is now 26. And then I can say that b is 28. So my brother is 28 years old. Okay. All right, so that's a nice and simple version of substitution. I'm going to do a more complicated version of substitution down here. Okay, so let's say we have 2x plus 3y equals negative 17, and 2y equals 6x minus 4. Okay, so like I said, this is best used when one variable is isolated. This top equation has x and y on the same side and coefficients for both. This bottom equation has y by itself, but it has a coefficient. So what we can do is divide everything by that coefficient, and now I have 3x minus 2. Y is now solved for by itself. So I can plug that y, this expression, in for up here. So I'm going to come on over here and say that 2x plus 3 parentheses, I'm going to plug this whole thing in, equals negative 17. Okay, so again, I'm just plugging it in for the y. Now, up here, we didn't have a coefficient in front of b, so we didn't have to multiply or distribute. We have a coefficient in front of this 3, or in front of this y. It's a 3. So I have to multiply 3 by both terms on the inside to simplify. So 3 times 3x is 9x. 3 times negative 2 is negative 6. Okay? So again, I isolated the variable and I substituted it in. Now I'm going to solve for my one letter x. So these are like terms. They add to make 11x. And now I'm going to do inverse operations. So if we add 6, 11x equals negative 11. Opposite signs, we subtract, keep the sign of the bigger number. Divide by 11, we get x equals negative 1. Okay? Now, I'm going to come back over here, and this x is going to get plugged in to this equation. So we have y equals 3. X is negative 1 minus 2, so that x became negative 1. Y equals 3 times negative 1 is negative 3 minus 2. Same signs, we add the numbers and keep the sign. So y is negative 5. Okay. Our final solution, we have to write it as a point. So x goes first, y goes second. That's my final solution. Okay. So sometimes you just need to either divide by a coefficient or move a variable. But if we can isolate that one variable, whether it's x or y, we can then substitute, solve for one variable, and then using that variable, we go back to the isolated one and we plug it in. That's how you do systems by substitution.